Now that we finished our profile, we need to move on and finish creating our cluster. We'll begin with the versions. Under versions, we can just borrow the versions we created for the profile and add them here. So for versions of the cluster module, we have to add another required provider. Just to duplicate this one, and then I'll change the name to time, and then it will be /time, and the version of this one will be greater than or equal to 0.9. You can close the versions file, and let's create the variables quickly. So the variables will be split into several sections. We start with the common section that will contain the common variables. So we have var name. This is the project name. These are required variable, therefore no default. The second one will be tags. This will be a map of strings. We'll use the resource tags. The next one will be the module unique ID. We'll use the name unique ID. Then we have the VPC ID. This one will be the VPC identifier. Next variables will be the IAM variables. For these ones, it will only be one, and its name will be IAM role path, and I will name it cluster IAM role path. The role path is usually used to group roles or users within an account that has many organization users. Next block will be for KMS, and for this one, we are creating a variable named KMS deletion window in days. This one will be a number, and it will indicate the deletion period for the KMS key. These are the number of days after which the key will be permanently deleted after it's marked for deletion by you. So by default, we'll set this to 30. We have the EKS section. So the variables under this section will start with this enable cluster encryption. This will be a Boolean. And as the name states, the description will just read the same, enable cluster encryption. And the default value will be false. Can pass in the cluster version as the next variable, which will be a string. This will be the EKS cluster version. You can compare this to the Kubernetes version that will be installed. By default, we are using version 1.29. Then next will be subnet IDs, which will be a list of strings. And then we'll have the security group IDs. Lastly, we'll have cluster timeouts. So for the type, it will be a map of strings. The default value will be create, set to null, update, set to null, and delete, set to null. Next, we have the add-ons variables. Here we start with the cluster add-ons, which will be of type any, and the description will be cluster add-ons. We can add an example default here for reference. So just like this. This is an example of the plugins that can be passed, but we won't be enabling it because we want the user to specify this. We have the data plane wait duration, which will be a string. And the description of this variable will be the duration to wait after the EKS cluster has become active before creating data plane components. The data plane components are items like Fargate profiles, managed nodes, and you have self-managed nodes. Default will be 40 seconds. Then we have cluster add-ons timeouts. This will be the same as the ones for the cluster timeout. So you can just copy this default, add it below the description, and here we can just add EKS cluster add-ons timeouts. Then we have cluster encryption configuration. This will be of type any, and it will carry the encryption configuration for the cluster. The default will be a map that has resources in it, and for the resources we specify secrets. Lastly, we input the CloudWatch variables. For this, we start with the log group creation. So we specify the create CloudWatch log group variable, which will be a Boolean, and the description can be a question, create CloudWatch log group, and the default value will be false. Then we need to specify the cluster enabled log types using this variable, enabled cluster log types, which will be a list of strings. So the description will be a list of enabled cluster log types, and the default value will be an empty list. Next variable will be CloudWatch log group retention in days. So the description will be days to retain the log group logs, after which they are deleted. Default, we pass in 90, and we change the type to number. So we have CloudWatch log group KMS key ID as the next variable. It will be of type string, and this will be the KMS key used to encrypt CloudWatch log group. By default, it will be null. Lastly, we create the Fargate profile block. The first variable here will be Fargate profiles, which is the only variable. Type will be any. The reason we are using any is because this object can take any structure that cannot be predetermined by an object type or a map. And description, we just say specification for the Fargate profile. And for the default, you can just add an example of the structure that can be expected. Then the first key will be apps. The name will be apps. Selectors will be an array. Then we can add a namespace selector. And then here we can add labels. Should be an object. Then we can just add any label that we'll use in our app. For this case, I'm using this one. Name is equals to app. And add a second selector that shows an example of using a wildcard. So we can just copy the first one, paste it here, remove the comma. Then for this one, we'll be using app-wildcard star like this, so that it can match any namespaces that begin with this prefix and any labels that begin with this prefix. The selectors, we pass in subnet IDs, which will be an array of strings, and we pass in the unique ID, which will be apps. Then we can specify timeouts. Here we just specify create and delete. Instead of writing minute in full, just write M, fix that one. Then we can indicate whether we are creating IAM role for the Fargate profile. Then the next one will be IAM role attach CNI policy. So this one we can pass in false. Then we have the IAM role additional policies. Here we can just pass null. And we have the policy execution assume role ARN. This will be null too. And then we have tags, which will be an empty object. So this is a sample of the default variable. We can comment it out so that we have a reference within the variables.tf. This marks the end of the cluster variables. You can see we have the common variables at the top here. We have the role variables, KMS variable, EKS variables, and then EKS add-on variables with an example here for the add-ons. And then we have the CloudWatch group variables. Finally, we have the profile variable, which is only one variable and with its example commented out. Next, we'll go to the data resources. We start with the AWS partition, and here we'll just name it current. Have that IAM policy document, which will name it assume role policy. And here we'll have a statement block with an ID of EKS cluster assume role. The actions will be STS assume role. Then for the principals, the type of the principal will be service, and the identifier will be EKS.Amazon.AWS.com. Next, we need to specify a data resource for AWS EKS add-on version to be named main, and it will be created using count. Instead of count, we can use for each to loop through the object. Then with for each, we are transforming the map of the object in var.cluster add-ons. We are returning the value if var.cluster add-ons is not equals to null, or we can just change this to check if the value is not equals to null. For this to work, we need the add-on name, of which we'll try two values, the name from the value of the map. If the value is empty, we take the key. Then the Kubernetes version will come from a queries of var.cluster version and AWS EKS cluster.main.version. We'll be creating this in the main.tf. So in case this value is null, then we'll read the version from the cluster itself. And then coalesce will remove any null value from this list. So it will pick the value that is not null. Then for the most recent part, we try each.value.most recent. If it's not set, we pass null. That's the end of the data resources that we'll be using. Next will be to configure our local variables. And here, we only have one variable, the cluster name, and it will be created from two variables and a string. So we'll use the project name plus the unique ID, and then at the end we can just add Fargate cluster, or we can just add cluster like that. So choose any string you want to use. Take note of this name. This is the project name that will come from main.tf, from the main variables. So this project name is the one we used to configure the IAM user for the cluster. So whenever we were referring to this cluster, we didn't input the whole name. Instead, we input the project name -wildcard to match any clusters that will be using this project name with any other name after the hyphen. That's it for the locals. Now it's time to configure the main.tf. We'll start with the KMS key. And for this, we'll be using a module from the AWS provider on Terraform. The module will be named KMS key. The source will be Terraform AWS modules, KMS/AWS. And then the version will be version 2.1.0, a string. Will indicate if you are creating these resources based on this variable. For the description, you can add your own description. So this will be the cluster encryption key. And for the key usage, it will be encrypt_decrypt. And the deletion window in days will be the var.kms key deletion window in days variable. Finally, we'll finish with tags and pass in var.tags. Next, we are going to create the IAM role and its dependencies. It will be AWS IAM role. It will be named assume role. The name of the role will be created from the project name, the module unique ID, and a string assume role at the end. We'll pass in the path using this variable var.im role path. Pass in the description. So I'll use IAM assume role or EKS. And we have assume role policy, which is data. This is the data resource that we created, .json. Don't forget to add .json because this one expects a JSON string. Then now we specify if we'll first detach policies. Here I'll hard code this. You can pass this as a variable if needed, and you can omit it completely if you don't want that behavior. And then for the tags, we'll pass the tag variables. Next, we want to attach the AWS managed policies to this role, and we'll be separating the managed policies from an additional policy that we'll be creating based on the KMS key. So we'll start by creating the AWS role policy attachment for the managed policies. And here we can just say managed policies as the name. Inside here, we'll use a for each, and then we'll create our own object and then map through it. So we have for key value in, and then we create the object. The first key will be Amazon EKS cluster policy, and the ARN of this policy from AWS IAM console will be this. Then I'll just create the second key, which will be Amazon EKS VPC resource controller managed policy. Its ARN from the IAM console is as follows. Here we add the condition. We are returning the value if true. Each of these values, we are sure they are passed in. So we are just returning the value with a Boolean true because we know they are already populated. That's the end of the for each block. So we just need to pass in the policy ARN from the for each. So we'll do each.value. And then for the role, we'll be using AWS IAM assume role.name. We forgot to put if here. So the for loop expects a condition at the end. After you supply the map, you specify the condition in which the for loop will return the values. So this condition has to return a Boolean. We can even make more sense by saying v is not equals to null. This one will always return true because we know our values here are supplied. Lastly, we need to create the IAM policy and then attach it to the role. This IAM policy depends on the KMS module, so it cannot be added here under for each, or else we'll get the error of for each complaining that it cannot depend on attributes that can only be read after apply. That's why we are creating this additional policy. So it will be a resource of type AWS IAM policy, and it will be for the cluster encryption. It will be created based on a condition. The condition we use to create the KMS key, this one, a Boolean variable. So we check if this variable is true, we create, else we don't create this resource. The name, this policy will be as follows. It will be created from the project name and the unique ID of this module. Then we can pass in a description, EKS cluster encryption policy, and then we'll pass in the policy. Here we are not using the data resource. I'm using JSON encode to show you an additional approach you can use to pass in a policy document. Then this document will be using a version of 2012-10-17, and the statement will be as follows. So it will have an action for KMS encrypt, decrypt, list grants, and describe. The effect of these actions will be to allow them, and then they'll apply on the module KMS key ARN. Then lastly, we pass in the tags. Here we'll use the merge function. We'll be merging var.tags with the name that we are using here. And then we have to finish by attaching this. So we'll create an IAM role policy attachment. We'll name it cluster encryption. It will be created based on the same condition as the one here. It will be based on whether cluster encryption was enabled. And for the policy RN, we'll read it from this policy. Make sure when you're reading this policy, you use an index because it's created by count. And then for the role, using the assume role.name. Just confirm, make sure you are referencing the correct resources here. Next, we'll be working on the EKS cluster.